Hey everyone, welcome back to the channel. If you ever wonder why your React Native app feels junky, drop frames during the animations, and scrolling stutter, the real reason is the architecture. And most of the developers don't actually understand why. So in today's video, we are going to go deep down on exactly how React Native works under the hood and why Meta rebuilt the entire architecture from scratch. So uh, when you write a React Native code, eventually you are writing a JavaScript. That's the whole point. One single code use for both platforms. And there's the thing nobody talk about. Your phone has no idea what JavaScript is. Android speaks Java and Kotlin. iOS speaks Objective-C and Zip. That's it. That's the native language of the device. And so when your JavaScript code want to do something natively, like open a camera, access GPS, or send push notification, that's the gap. JavaScript on one side and native device capability on another side. So React Native need a way to allow JavaScript to communicate with the native side. So they built something called the bridge. And for years, it worked. App were built, product shipped. But when app have more complex, like more animations and more real-time updates, the developer going to hit a well. And the animation that looked perfectly on the simulator would shutter in the real device. The scrolling that felt smooth during the development, but drop frames during in the production. The budget and the device felt completely different from the simulator experience. And most developers couldn't explain why. The real reason is always the bridge. So let me show you how the bridge actually works. So these this is your JavaScript code. So this is your JavaScript code. So when you JavaScript code want to access any native modules, like right, so to they can't able to directly access the native modules or the native APIs. So what happened? They first of all serialize that JSON serialize the request into a plain JSON message because the bridge only understands the JSON. So they serialize the request into a JSON message, put it on a bridge. This bridge carries the JSON message to the native side. On the native side, they deserialize that JSON message to know actually what JavaScript requesting for. Like they want to open a camera or access the GPS, whatever, right? So they first of all understand what JavaScript requesting for. Then they perform the specific task. Then generate a response. And again, they serialize that JSON response they serialize it again into a JSON message and put it on a bridge. So the bridge again carries the JSON response and give it to the JavaScript. So JS side, they again deserialize the JSON response and then your promise or the callback was resolved. For opening, for example, if you want to open a camera, this is fine. A few milestone doesn't matter. But what happen when your app need to do this hundred of times per second? That's where everything breaks. So let's take an example. If you want to open a camera, so here, when you call the camera like using any package or anything, so what happened under the hood? The first of all, JavaScript serialize the request. Like if you serialize the request into a plain JSON message, so they put it on a bridge. The bridge carries that JSON message to the native side. On the native side, they deserialize the JSON request and understand actually what JavaScript actually requesting for. Like if you want to open a camera, so they know JavaScript request for the camera module. So they perform the specific task and generate a response and again serialize the response into a JSON message and put it on a bridge. The bridge again carries the JSON response to the JS side. They deserialize the JSON message and then this promise was resolved and you can able to access the camera. That's the whole point. Why the bridge was slow? The real reason is the serialization cost and asynchronous on. So we just see like how the if you want to open a camera, how this actually under the hood work. So uh, every single message across the crossing the bridge had to be convert JSON and back to back. both direction, like in the JS side, in the native side. So these your JavaScript object. They first of all serialize it and serialize it into a JSON string. This JSON message, put it on a bridge. This bridge carries from the native side. On the native side, they no like JavaScript request for the camera model. So they perform this task. And again, these again serialize the JSON response, put it on a bridge. This bridge carries the JSON response and deliver to the JS side. The JS finally get the response, and then you can able to open the camera. But now think about what happened during the scroll. The every pixel your finger moves and generate an event. Every touch, every animations, the frame updates at 60 frame per second. The React Native need to send a new animations value across the bridge 60 times every single second. The positions, the opacity, scales, the transform, all converted to the JSON, sent across bridge, converted back to back over and over. That's over 100 serialized operation per second for just one single animation. This is not a free. It costs CPU, it costs the memory, and it added up fast. This is why your app feels slow on a budget Android device. Even when your code looks completely fine, the serialization overhead is eating your performance budget before your code even runs. The second biggest issue is asynchronous. The bridge was completely asynchronous. There was no way for JavaScript to call a native function or native object and get immediate answer back. So every time when JavaScript requesting something from the native side, they just fire and forget. They send a message and they doesn't wait. They didn't wait. So think about what that means. Like you need to read something from the storage right now, synchronously, before rendering. You can't do it. You need to measure a view, exact dimension before laying out and rendering out. But it you can't do it. Something that depend totally on the dimension. Right? Everything had to be designed up around the fallback and the promises. Not because that was the right design, but because the bridge forced it. This is actually why async storage has to word async in the name. It wasn't designed job. It's the bridge literally couldn't support the synchronous rate. The transport layer was dictating how your entire code was had to be written. So the biggest bottleneck is see this diagram. We have a touch event, animation frames, the network response, storage access, and other events. This all events, every single event of this has to go through the single lane of the same bridge, one channel, one queue, and one lane. So imagine you are in a highway with a 6 lane of traffic, right? So, but there is a single turn off in the middle. That's the bridge. And here's the painful part. There was no priority stuff. A high priority touch event had to be wait for the low priority background task. The everything queued, everything wait. The high traffic means the combinations. The combinations means the delay. The delay means the drop frames. This is why adding more animation to a screen made everything worse. They weren't just expensive individually. They were all competing for the same single lane. Every animations you added for made every other animation worse. And the painful part is the animation junk. So smooth animations require 60 frames per second. That means one frame every 60.67 milliseconds. This is your entire budget for everything. The JavaScript calculates the new animations value, serialize it, send them across the bridge. Native side, they receive them, deserialize them, and update the view, render the screen. All of that in under the 16.67 milliseconds. On a powerful device with a zero load, sometime it's made. But the moment there's any bridge combinations, any other message in the queue, any JavaScript execute happening at the same time, you miss the deadline. You miss the deadline means drop the frame. And drop the frame means user see the stutter. They can feel immediately like this app is uh, freezing or performance very poor. The user don't know what happened under the hood, why the app is feel heavy. So they just know the app feels cheap, right? So and on lower end Android device, which is the majority of the global Android market, this wasn't the edge case. It was the normal experience. This is exactly reason the exact reason the React Native reanimated exists. The entire purpose of the library. One of the most used library in the entire React Native ecosystem was move animations logic completely off from the JS thread to run animations directly on the UI thread to just bypass the bridge entirely. Think about it. The entire major library used by almost every serious React Native project, built specifically because the architecture was too slow for the animations. When your code, when your core framework require a third-party library to bypass its own architectural limitations for a basic use case, that's tell you everything about how the broken architecture was. So this is how the React Native works with the old architecture and why most of the developer have complained like the poor performance and everything. So in the next video, we are going to understand how the new architecture works, how they solve these issues and improve the overall experience and improve the overall performance of React Native applications. So if this video helped you to understand something that wasn't clear before, so please like and subscribe for more React Native videos. See you in the next video. Happy coding.